Hey guys, I am going to try this because I think this is going to be easier than trying to write things and hold it up to my screen, so we'll see how this goes. But the thing that I have on the schedule for you guys for Tuesday is finding the lengths of arcs and areas of sectors. So just to recap what we've done so far, as we've talked about finding the measures of arcs. So for example, if we looked at these two different circles that both have a central angle of 45 degrees, meaning the vertex is at the center of the circle, we know that because it's a central angle, that the measure of the arc here, AB, is 45 degrees, and the measure of the arc CD here is 45 degrees. So the measures of those two arcs are the same. But when we're talking about the length of the arc, in this circle, where we just have a smaller radius, we will have a smaller arc. In other words, its length will be shorter than the length of this arc in the circle that has a radius of 6. So we're talking about the actual physical length of it, not just the measure, the degree measure of it. All right, so then the question that we come up with is, how do we find the length of an arc? So let's just go through this bit by bit, because I think you'll find it's pretty straightforward. So let's just say we were talking about the length of this whole arc right here. In other words, the circumference. How would we find that? So you should remember that formula. So I'm going to give you a second to think of it. All right, so it's the circumference, and it's 2 times pi times the radius. All right, so here we would say that the circumference of this circle, or the measure of the arc length, which is the whole outside there, is 2 times pi times 6, or our circumference is 12 pi. Now, because the circumference is a length, it would just be measured in inches here. All right, now let's say that we went on to this next example where we want to know what is the length of this arc right here, A, C, B, and I made it so that it was half of the circle, all right? So if we were to do that, hopefully it's pretty obvious then that it should be the whole circumference, which we just found in the previous problem to be 12 pi, but we just want half of that, all right? So we would take and divide it by 2. Actually, then let me not call this C. Let me just call it the length of arc ACB, which we just write as ACB without the arc length symbol over it. So we would take the whole circumference and we would divide it by 2, because we only want half of that. All right, so we would end up getting that the length of ACB was 6 pi inches. All right, next example. All right, how about if we wanted to find the length of arc AB right here? Well, if we use this example that we did in the previous problem, we only wanted half of it right here, so we found the whole thing and we divided by 2. So thinking about that, what do you think you would do here? All right, so if you said that the length of arc AB is the whole circumference divided by 4, you would be correct, because again, if we extended this, we would cut this into 4 equal segments, and we would just want 1/4 of it. So we would do 12 pi over 4. And again, I keep using 12 pi because that's the example that we started with up here, and then we just keep using it, giving you the same the same radius every time. All right, so here it would be 3 pi inches. All right, now let's just talk about this pattern a little bit, because here I did the entire circumference, all right? And so I could say that the angle measure that I used, if we're going from here, I went the entire way around here. So I used 360 out of 360 degrees, whoops, which just reduces to 1, right? Here I would say this angle right here is 180 degrees out of the full 360, and so that reduces to 1/2, and hence that's why we divided by 2. It's the same as multiplying by 1/2. All right, same thing here. We used up 90 degrees of the 360, which gives us 1/4, and again, That is why we ended up dividing by 4, because we wanted 1/4 of the circumference. All right, so then let's look at another example and see if we can generalize this. All right, so now we have 60 degrees. It's still a nice angle, but not as nice as the others that we just did. So I would say, and again, I'm still using 6 inches. We're going to change that in just a minute, but I just want you to really focus on the pattern here. All right, so if I were to find the length of arc AB, well, if I were to use the same reasoning that I did just a second ago, I would say, well, here I'm using 60 out of the 360 degrees in the circle, and that reduces to 1/6. All right, so the length of AB would be our circumference divided by 6, or another way you could write that is 1/6 of the circumference. All right, and that would be 1/6 times 12 pi. Again, the 12 pi came from that very first one that we did, and here we would end up with 2 pi inches. All right, let's try the next one here. Okay, so if we were to find the length of arc AB, and I keep using the same letters but changing the angle there. So this one's got a 45-degree angle, still a 6-inch radius. All right, so what fraction of the circle would we be talking about? I'm stopping so that you can think. All right, so hopefully you realize it's 45 degrees out of the 360 degrees. All right, if we reduce that, 9 goes into 45 5 times, 9 goes into 360 40 times, and then 5 goes into 5 once, and 5 goes into 48 times. So we would say it's 1/8. So we would take either circumference divided by 8 or 1/8 of the circumference, and we would get 1/8 times 12 pi. Right, 8 goes into, I'm sorry, 4 goes into 8 twice, 4 goes into that 3 times, so we would end up getting 3/2 pi inches, or 3 pi over 2 inches. All right, so I'm going to write the formula in general this time instead of keep figuring it out here on the side first. So we would find the the length of arc AB is whatever the angle measurement is in the center. We're going to call that theta, just like we've been doing for our trig problems. And we divide by 360. That's the part that we've been doing over on the side here. But now I'm just going to put it right in the formula. All right, so that instead of doing it separately and then putting it in the formula, it's just already part of it here. Times, and then we are saying times the circumference, or the circumference divided by whatever that denominator was, or that fraction times the circumference. And again, remember, circumference is 2 pi r. Right, so this is the general formula that we're going to do. We're going to take the circumference, whatever it is, and then we're going to multiply it by theta, whatever our central angle is, divided by 360, because that's going to tell us what fraction of the whole circumference that we want. So here we're going to have, so this is the general formula. General formula for arc length. Okay, so in our case, AB is 120 divided by 360 times 2 times pi times 6. Again, we don't need to do this part for our particular case because we've been using the same circle the whole time. We could just fill in 12 pi, but I just want you to see how this is going to work when we get down to problems down here. All right, so 120 and 360 reduce, the zeros cancel out. 12 goes into 12 one time, it goes into 36 3 times. And then I'm going to notice that I can cancel out here too. This goes in once, that goes in twice, and so we end up with 4 pi inches. Okay, now I am going to cover up the answers here on these problems, but I just want you to, hold on, technological difficulties right here. Okay, I've got 2 problems here that I want you to try. Let me see if I can alter this when it's standing here. Okay, and get a little bit closer. Okay, so I want you to copy these down and pause the screen for just a couple minutes because I want you to work them out on your own. Now I will tell you that the reducing in these two problems is not quite as simple as the ones that we've done before, so it might take you a little bit longer, but again, you're just supposed to reduce right here. I want you to give the exact answer instead of the decimal version, because I want you to practice with these. When we get into the workbook, sometimes it's going to say, give the answer rounded to the nearest tenth or hundredth, in which case you can use your calculator. But for these, use your calculator just to cancel out factors, but I don't want you to turn it into a decimal. All right, and also notice that I've changed the radius in each of these, so you will have to find the circumference for each of those too. All right, and before I turn that off for just a second, I'm going to ask you to, hopefully you've got this copied down now on your paper, but just in case you don't, copy that formula down. And what I'm talking about is right here, the general formula, that it's theta over 360 times 2 pi r. All right, so go ahead and do those.